Hey guys, I'm going to discuss a solution of Prac class 10b. So let's start with this first problem. So let xn be a sequence of positive numbers. Assume that this ratio, the limit of this ratio is this, which is greater than 1, right? 2020 divided by 2090. It's a number which is this is a number which is greater than 1. Right? Prove that this sequence converges to, so diverges to infinity. This is called, the sequence diverges to infinity. All right. Right, this is the information. This ratio goes to this number as n tends to infinity. We know that. So here look at this number. This number is greater than 1, right? So then we can find, that means their x is a positive number r such that r in between these 1 and this number here, right? This is trivial, right? Then we can take epsilon, this number minus r, right? Definitely this one is a positive quantity, so we can select epsilon for this number, right? But we know that here this ratio converges to this number as n tends to infinity. Then we can write the definition. We can use definition of convergence sequence. That means their x is n naught, natural number n naught, such that for all natural numbers which are bigger than n naught, right, this statement is true. This statement is true. The difference between that sequence here, this one, difference between this one and this number is smaller than epsilon. This is the value of epsilon. We have taken that value. So for this epsilon value, the x is n naught, such that all natural numbers bigger than to this number, right? So this one is true, right? So we can simplify this inequality, right? So we can remove this modular sign, right? And I considered only left hand side here. So this one, this ratio minus 2020 over 2019 is less than the negative value of this, which is this. Then here you can see that you can simplify. Here you can cross this off. You end up with having this one, but this one is true for all n bigger than or greater than or equal to n naught, right? This one is important because here, so this implies this, this implies this, right? So now I cross multiply this by this number, then I get I can rearrange this inequality, right? So this one is true for all natural numbers which are greater than or equal to n naught. So let's subbing this number in to here, then you get x sub n naught plus 1, which is less than, which is greater than r x sub n naught, right? This one is true. This is now you can substitute n naught plus 1 as well, because this statement is true for n which are greater than or equal to n naught. Now you sub n naught plus 1, then you get x sub n naught plus 2 here, right? Which is bigger than, what do you get other side? R x sub n naught plus 1, this one. So then you can replace here, you know that x naught here, x sub n naught plus 1, this number is bigger than this one. Then you get this inequality from 1, you get this one here, this one. Alright, so you can do this for general capital N, right? So finally you can imagine that, so you can see that this number here is bigger than this number. Here, look at the pattern. If you have x sub n naught plus 1, so this number is less than r to the power 1 x sub n naught. Here, if you have 2 here, you have r squared, right? R squared times x sub n naught. Then if you have x sub n naught plus uppercase N, this number, by looking at the pattern, this number you can show that this is trivial, right? This number is bigger than r to the uppercase N x sub n. Right, that means you showed that. So this is your sequence starting from n naught plus 1, n naught plus 2, n naught plus uppercase N, right? So you showed that. So this value is greater than this one. This value is greater than this. This value is greater than that. Right? Here, notice R is a number which is greater than 1. Right? Since R is bigger than 1, right? There exists a positive value such that 1 plus A is equal to R. Pretty simple, right? Because R is a value which is greater than 1. So this A is a positive value, right? Now let's take R to the power N. Let's take the power both sides, N power. Then you get R to the N equals 1 plus A, everything to the power uppercase N. So you can apply binomial expansion. So this is first two terms of the binomial expansion. So because A is a positive number, 1 is a positive number, when you expand this one you get everything positive, right? So this is two terms of that binomial expansion. Definitely this value is smaller than this binomial expansion, full binomial expansion. So this is true. So that means R to uppercase N less than or equal to 1 plus uppercase N A. This is true for all uppercase N. These are natural numbers. This is 1, could be 1, 2, 3, 4, 5, like that, right? So that means, so this is trivial, right? As uppercase n goes to infinity, what happened to this term? This term also goes to, this term goes to infinity, right? That means here this number is bigger than this number. That means this one also goes to infinity, right? So this one also goes to infinity as a uppercase n tends to infinity. So if you multiply this number by a constant positive number, then what happens? This product also goes to infinity as n tends to infinity. That means this is a part of that sequence, right? So you have starting this is the start of first term, second term, this is x n naught plus uppercase, and this is the n naught plus uppercase nth term, right? So this sequence also goes to infinity as n uppercase n tends to infinity. That means so this is a part of this sequence. I mean this is a subsequence of that one. That means this sequence diverges to infinity as n tends to infinity. All right.